Hey guys, welcome back to my video. So as you know that yesterday my winter holidays have started and Christmas is coming in a few 10 days. As you can see here, my dad bought me one of the best lab bench power supply at 30 volts and 5 amps. So as you can see, I'll jump right into it. As you can see, there are 4 knobs and then 3 outlets. And there's a switch right here. Yep, that's how you switch it on. The black is always ground and the red is always positive. And you can see that there are 2 LED digits, and here it reads the voltage and reads the current. And so yeah, so this supplies about 30 volts at 5 amps, which is a really powerful, just at 110 volts AC. As you can see, I put it in this spacious area. I can't put it somewhere over there because that's my soldering table. Over here I build everything, so this is the only place where I can do it properly. And I also put a little space in the back because there's a cooling fan that cools down all the components inside. It is about like 1 kg, and so it's easily like portable and everything. Let me show you some applications for this. You can see here that I have a motor, an LED, a huge 12-volt battery I got from dumpsters, and then this special piece of equipment. It's called a thermoelectric module. I'll be explaining in another video. Let us see how the motor works. So this is voltage and amperage. So this is for like very fine. Like if you want to go to 0.01 volts, you can do that. But I want to use a coarse, which means fast. So let's take about, let's say 1.5 volts, okay? That's 1.5 volts. And then if you want to take the current value, you need to basically short them. And as you can see, the fan switch is on, and let us reduce the current value to 300 milliamps. Okay, so that's ready. We have all the values in place, and let us connect this to the motor. Simple. Let's not short it in the process and get my hand electrocuted, or I'm dead. Okay. You can see the motor spins at a decent rate at 1.5 volts. You can see it's not reaching 300 milliamps. It's only using 170 milliamps. Okay, and that's a continuous voltage. Let's increase the voltage, which means it's thereby going to increase the amperage and the rotations. You can hear it by the sound. Okay, let's get it up to 3 volts. 4 volts, 5 volts, 10 volts, and so on. That's 300 milliamps. So 10 volts at 300 milliamps. And so that's the motor. Let us use another device, an LED. Okay, so let us, as you know, let's connect the short end to negative and the long end to positive. Okay, now we need a low 2 volts and a 0.025 milliamps, or 25 milliamps, or 0.025 amps. Okay, so let us put it to amperage. We don't know what is that. At 4 amp. Okay, 1 volt. It's still not out. 2 volts. Look, it's up. Let us see. Okay, so at 2 volts we get a constant voltage and the LED glows. And and so on. We can also use it to charge this big battery here. All you need to do is plug in the ends, the leads properly, and on the meter here, here in the meter, it reads 6 volts. You increase the current, let's say 2 amps, and increase it to 12 volts. As you can see, the cooling fan switch is on because it's using a lot of power. And so that is going to charge this battery at 400 or 500 milliamps. And that is going to take about a few hours, like 5 hours to 6 hours, depending on how much amps we're giving to it. In the next video, we're going to be talking about this thermoelectric module here, which I'll be supplying 12 volts. And one side of it will become extremely cold, and the other will become extremely warm. Stay tuned, stay creative. Thank you guys for watching. See ya.